Dear students, now I explain hybridization. Okay, so hybridization is introduced by Pauling. So it was introduced by Pauling. What is meant by hybridization? It is the intermixing of atomic orbitals of almost same energy and their redistribution into equal number of hybrid orbitals. Okay, so here in hybridization, generally the center atom only involved. Sidewise atoms are not involved. Hybridization is related to central atom only. Okay, it is not related to sidewise atoms. So in central atom, same energy, almost same energy of orbitals, atomic orbitals are intermixed. Okay, after the intermixing of atomic orbitals of almost same energy, and then distribute into equal number of hybrid orbitals. Okay, so therefore, in hybridization, the number of atomic orbitals are equal to number of hybrid orbitals. Okay, so number of atomic orbitals are equal to number of hybrid orbitals. So this is the condition. Now here different types of hybridizations are there. So simply I am explaining that is the sp hybridization. So sp hybridization is intermixing of 1s and 1p orbitals to form two sp hybrid orbitals. Okay. So in sp hybridization, the percentage of s character is 50% and p character is 50%. Okay. So here more S character is given for sp hybridization. And with sp hybridization, the molecule structure is linear, bond angle is 180 degrees. So now in this examples are beryllium chloride, acetylene, carbon dioxide, etc. And next, sp2 hybridization. In sp2 hybridization, 1s and 2p orbitals are intermixed to form three sp2 hybrid orbitals. In this, S character is 33.33% and P character is 66.67%. Okay, so S character is medium when compared to sp hybridization. And structure is trigonal planar. Bond angle is 120 degrees. Okay, so here examples are boron trifluoride, ethylene, boron trichloride, sulfur dioxide, sulfur trioxide, etc. And next hybridization sp3. So intermixing of 1s and 3p orbitals to form 4sp3 hybrid orbitals. Here s character is 25%, p character is 75%. Okay, so s character is less. Now see in all this, the number of atomic orbitals are equal to the number of hybrid orbitals. 1 plus 3, 4 atomic orbitals are involved and 4 hybrid orbitals are formed. Okay, and in this, the structure should be tetrahedral. Bond angle is 109 degrees 28 minutes. Okay, and examples are methane, ethane, all alkanes, etc. And next, sp3d hybridization. 1s, 3p, 1d. Atomic orbitals are intermixed to form 5 sp3d hybrid orbitals. Here S character is 20%, P character is 60%, and D character is 20%. Now in this structure is trigonal bipyramidal. Bond angle is 90 degrees, 120 degrees. Examples PCl5, phosphorus pentachloride, phosphorus pentafluoride, like that. Next hybridization sp3d2. Okay. So 1s, 3p and 2d atomic orbitals are intermixed to form 6sp3d2 hybrid orbitals. Here structure is octahedral and bond angle is 90 degrees. Example sulfur hexafluoride. Sulfur hexafluoride. So these all are different types of hybridations. Okay. So for these hybridizations, you have to know the structure bond angles clearly. Okay. And next, how we determine the hybridization in a molecule. Okay. So hybridization is majorly related to center atom of molecule. So that's why how we find out the center atom, sorry, how we find out the central atom exhibits which hybridization. So here, now, for single central atom of molecules only. Okay. So means in some compounds, two central atoms are there, no? Like in acetylene. In acetylene, two carbons are the central atoms. In ethylene, two carbons are the central atoms. In ethane, two carbons are the central atom. Okay. So that's why this formula is not applicable for those molecules. So it is applicable for single central atom of molecules or ions. Molecules or ions, hybridization is found with this formula. So what is there? So electron pair is equal bond pair plus lone pair. Okay. So I wrote that in simple manner. Electron pairs. So EP indicates total number of electron pairs. BP number of bond pairs. LP number of lone pairs. Now see that. Based on number of electron pairs only, the hybridization is explained. Okay. So if the number of electron pairs are 2, then the center atom exhibits sp hybridization. If that are 3, sp2 hybridization. 4, sp3 hybridization. 5, sp3d. 6, sp3d2. 7, sp3d3 hybridization. Now see that bond pairs. Bond pairs are equal to what? Number of sigma bonds in a molecule. Number of sigma bonds only. Okay. We will not take up pi bonds. So number of sigma bonds only equal to bond pairs. And next, lone pairs. Lone pairs is equal. Here a formula is used. Half G. G means group number of center atom. Group number or its valence electrons. Okay. Minus its valency. In that molecule, it has some valency, no? So that valency will be given here. Plus anionic charge. So A indicates charge of anion. Minus C, charge of cation. Charge of cation. Okay. By knowing bond pairs and lone pairs, we will get electron pairs. Okay. With electron pairs, we easily find out the hybridization of that molecule. Okay. So now see some examples. So here I give it some molecules as well as ions. One is methane molecule. So in methane molecule, center atom is what? Carbon. Okay. So that carbon is bonding with 4 hydrogens. Therefore, here bond pairs are 4 and lone pairs are 0. Okay. So lone pairs are 0. So that will be explained with this formula. So see here, lone pairs. How we find out the lone pairs? Okay. So for that, here I will explain in case of methane. So write half group number. Carbon belongs to fourth A group, no? So 4 minus its valency is again 4. So there is no charge, no? So that's why 4 minus 4. So that is equal to 0. So that's why here I wrote that is 0. Okay. So therefore, here in methane molecule, bond pairs are 4 and lone pairs are 0. Lone pairs are 0. Therefore, in methane molecule, carbon exhibits sp3 hybridization and its structure is tetrahedral. Okay. And next, ammonia. In ammonia molecule, center atom is nitrogen. Bond pairs are 3. And see about lone pairs. Half. Group number. Nitrogen belongs to fifth group. Minus. In ammonia molecule, nitrogen valence is 3. Okay. So 5 minus 3. 2 by 2 that is equal 1. So therefore here total electron pairs is equal 3 plus 1 that is equal 4 Therefore, it exhibits sp3 hybridization. But with sp3 hybridization, the molecule structure is not similar to tetrahedral. Here, the structure is pyramidal. Okay. So, why? Due to having lone pair, electronic repulsion occurred. So, therefore, its structure is different, as well as bond angle also different. Okay. And next example, PCl6 minus. Okay. Hexaphosphorus ion. Sorry, hexachlorophosphorus. Now here, in this bond pairs are 6, lone pairs are half, 5. It is fifth group of element, no? Therefore 5 minus 6. Its valence is 6 plus charge of anion. So that is plus 1. So therefore that is equal to 0. Now finally here electron pairs are 6 plus 0, that is equal to 6. Therefore hybridization is sp3d2. With sp3d2 its structure will be octahedral. Its structure will be octahedral. So this is about hybridization and how we find out hybridization in each molecule or ion when it contains one central atom. Okay. So that's why these formulas are important and it is easy way to find out the hybridization. Okay. So objective purpose, these parts only useful. And next, VSEPRT theory. Next about VSEPRT theory. So it was proposed by Sidgwick and Powell, developed by Gillespie and Nyholm. Simply, I explain some points. Okay. According to this, VSEPRT theory, the shape of molecule depends on number of electron pairs in the valence shell of central atom. In the valence shell of central atom. Okay. So according to this theory, electron pairs are two types. In any molecule, the electron pairs are two types. That are bond pairs, lone pairs. Okay. So according to this, in between of these electron pairs, repulsions occur. Okay. Those repulsions are arranged, those repulsions are more in between two lone pairs than lone pair than bond pair bond. Okay. So due to these repulsions, the structures of molecules are changed. Okay. So that explanation is given by this VSEPRT theory. Till now, with hybridization, just they given the structures, but for that there is no reason. But this VSEPRT theory explains the structures of the molecule that is differed that are majorly due to these repulsions. Okay, so that repulsions are more in between two lone pairs than lone pair bond pair than bond pair bond pair. Okay, so now this theory given one of the table. Now see here different formulas of molecules are given. Okay, so first here AB2 molecule exhibits sp hybridization. AB2 molecule means A is center atom, A is bonding with two B atoms. Okay, so that's why here we mention that as A. A is center atom in all these formulas that was only there. Here this AB2 molecule exhibits sp hybridization. Okay, so why that exhibits sp hybridization? Here bond pairs are 2 and lone pairs are 0. So 2 plus 0. So therefore total electron pairs are 2 only. No? So that's why that exhibits sp hybridization. Then the molecule structure is linear and examples are given. And next, for AB3, AB2E molecules, here two different formulas are given. So see that AB3, AB2E. E means what? E indicates about lone pairs. Okay. E indicates about lone pairs. So in AB3 formula of molecule, three bond pairs only present without having lone pairs. Okay. So therefore its structure will be trigonal planar. But when it has one lone pair along with two bond pairs, then the structure is defined as bent structure or V-shaped structure or angular structure. Okay. So that is majorly due to what? Due to electronic repulsions. Okay. So VSEPRT theory explain about repulsions, no? So that's why by the presence of lone pair, there is a repulsion occurred in between lone pair and bond pair. Therefore, its structure is changed to bent. Okay. Now, see in this, the total number of electron pairs are 3 plus 0, 3 only, 2 plus 1, 3 only. Therefore, these two formulas of molecules exhibit sp2 hybridization. And next three formulas are similar, like AB4, AB3E, AB2E2. Okay. So here one lone pair is present, two lone pairs are present, zero lone pairs are present. Okay. So that's why here total number of bond pairs are 4 plus 0, that is equal to 4. 3 plus 1, 4. 2 plus 2, 4. So in all these total number of electrons pairs are 4. So that's why these molecules exhibit sp3 hybridization. But due to electronic repulsions, the structures of molecules are changed to tetrahedral, pyramidal, angular. Okay. So when one lone pair is there, then the molecule structure will be pyramidal. Okay. Generally, we know that important example is ammonia. And when two lone pairs are there, then the structure of molecule will be angular. So for that important example is H2O. Okay. So this due to these repulsions only, the structures of molecules are changed. So majorly remind that part. That was only explained by the VSEPRT theory. And next, again, here four different formulas are given by the exhibition of sp3d hybridization. One is AB5, AB4E, AB3E2, AB2E3. So here bond pairs are 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3. In all these cases, total number of electron pairs are 5 only. Therefore, these molecules exhibit sp3d hybridization, but the structures are different. When zero lone pairs are there, then it exhibits trigonal. Its structure is trigonal bipyramidal. When one lone pair is there, its structures are seesaw. Two are there, T shape. Three are there, linear. Okay. And next case, sp3d. So here I took that different formulas. What are the AB6, AB3E, AB4E2? Okay. In all these cases, the central atom exhibits sp3d2 hybridization only. Okay. Now see that number of bond pairs are 6 plus 0, 5 plus 1, 4 plus 2. So total number of electron pairs are 6 only. Therefore, these formulas of molecules exhibit sp3d2 hybridization. But structures are different. See that. Octahedral when lone pairs are equal to 0. Square pyramidal structure. So when central atom has one lone pair. Square planar structure where central atom has two lone pairs. Okay. So that's why all these are the important points in objective words. Okay. And next topic is the coordinate covalent bond. Coordinate covalent bond or dative bond. Okay. So coordinate covalent bond also a type of covalent bond. It is a type of covalent bond. How a covalent bond is formed? By sharing electrons. So here also electrons are shared, but those electrons are donated by, contributed by one of the atom, one of the atom. Okay. So therefore, it is formed between two atoms by the sharing of an electron pair, which is donated by only one of the two atoms. Which is donated by only one of the two atoms. So it is represented by arrow mark. So that arrow mark indicated from donor to acceptor. Donor to acceptor. Okay. So here example is formation of ammonium ion. Formation of ammonium ion. So how that ammonium ion is formed? So in this, see here. First we have to take off ammonia molecule. In ammonia, nitrogen has one lone pair. Okay. And ammonia is reacting with what? Hydrogen ion. So it is a cation. No? So therefore, this hydrogen ion has one vacant orbital. When one atom has lone pair and the other atom has vacant orbital, then only this coordinate covalent bond is formed. So here nitrogen donates its electron pair to hydrogen ion. It accepts that electron pair and that electron pair will be shared from ammonia and hydrogen ion that are shared from ammonia and hydrogen ion. Okay. So therefore, here donor is ammonia, acceptor is hydrogen ion. Therefore, here arrow mark is indicated from donor to acceptor. From donor to acceptor. Okay. Now, here this dative bond of molecules and ions. So generally some more examples also there. Okay. So nitrous oxide, ozone, dinitrogen tetroxide, dinitrogen pentoxide, carbon monoxide, ammoniated boron trifluoride, borazole, aluminum chloride, hydronium ion, ammonium ion, nitrate ion, boron tetrafluoride. Okay. So these are some more examples also there. And next, one more point. In complex compounds, dative bonds are present. So majorly complex compounds are coordination compounds. Okay. So coordination compounds are complex compounds. Dative bonds are compulsory present. Now for this, see that these are the some of the examples. Now how that coordinate covalent bonds are observed. So for that, see the example. I write the structure of aluminium and next here six water molecules donate their electron pairs to aluminium ion. Six water molecules. Okay. Six water molecules donate their electron pairs to aluminium ion. Okay. So now see in this complex compound, six dative bonds are present. How that are formed? On each oxygen atom, two electron pairs are there. So that electron pair, one electron pair should be donated from one water molecule. All these electron pairs are accepted by aluminum. So therefore, in between of that water molecules and aluminum ion, coordinate covalent bond is present. Okay. So therefore, that is about coordinate covalent bond. That is about coordinate covalent bond. Okay. And next, the total number of covalent bonds and dative bonds made by an atom is known as its covalency. So covalency is one of the important one. Okay. So made by an atom is known as its covalency. So see this. In this molecule, what is the covalency of aluminum? See, around aluminum, how many bonds are observed? Totally six. Either there should be dative bonds or covalent bonds. Okay. So therefore, in this complex compound, the covalency of aluminum is 6. Why? Around aluminum, 6 coordinate covalent bonds are observed. No? So the number of coordinate covalent bonds or the number of covalent bonds, okay, of an atom is known as its covalency. So now, here one example also I give. In sulfate ion, covalency of sulfur is 6. Okay, in sulfate ion. How we write? So see this sulfate ion. I write sulfate ion structure. Just a minute. S double bond O, double bond O, double bond. So single bond O minus and single bond O minus. So this is the structure of sulfate. So now see that around sulfur, how many bonds are observed? So that are 2 plus 2 plus 1 plus 1. Totally 6 bonds are there. No? So therefore, in sulfate ion, covalency of sulfur is 6. In sulfate ion, covalency of sulfur is 6. Okay. So these are the general explanations. In next class, I will explain about molecular orbital theory in simple. Okay. I'll explain about molecular orbital theory and hydrogen bond. After the completion of that molecular orbital theory and hydrogen bond, I will give some important examples related to JEE Mains and NEET and advanced. Okay, so that's why please watch this video. Okay.